Hi guys, welcome back to CalcFly videos. In this new video, I'm going to be talking about a very useful derivative trick for especially implicitly defined functions. So in this case, we have this function that is defined implicitly f of x comma y, and if I try to take the derivative of this function, and if I apply the shortcut method, this derivative is going to be equal to negative f prime x divided by f of f prime y. So in this case, f prime x means I'm going to take the derivative of this expression of any kind of implicitly defined function, and I'm going to treat the y variable as like constant. Okay, that's why I'm going to be finding this partial derivative, and divided by, I'm going to be doing the exact same thing. I'm going to take the derivative of this implicitly defined function with respect to y, treating the x variable as like constant. Then I'm going to find the ratio, and that ratio is going to be my answer. Alright, so let's get started. Let's try to put all these things in motion. So we're going to solve two problems. In the first problem, we have d over dx is equal to x squared times y plus e to the power of x times sine y. So as you can see that this function is implicitly defined. So first, let's try to figure out f prime x. That means I'm going to take the partial derivative of this expression with respect to x, and that'll be equal to 2x times y. As you see that I'm going to treat the y variable as like constant, plus e to the power of x times sine y. So that's the partial derivative of x. Okay, then let's try to figure out the partial derivative of this expression with respect to y. Then f prime y is going to be equal to x squared plus e to the power of x times cosine y. Okay, so we got all this information. Then let's try to apply this formula. So d over dx x squared times y plus e to the power of x times sine y is going to be equal to, if I put this negative sign and division bar, so 2 times xy plus e to the power of x times sine y, that's f prime x, divided by f prime y, which means x squared plus e to the power of x times cosine y. Okay, normally we know the method about how we need to figure out the implicit differentiation. So basically, you're going to take the derivative of each expression with respect to x. So when you do that, when you take the derivative of y, you need to also add dy over dx and try to solve this equation for dy over dx. It'll take a little bit longer than this process. So that's why this process is very useful for especially implicitly defined functions. Alright, so let's carry on to the second problem. In the second problem, we got this function, cosine of x squared plus 2y plus x times e to the power of y squared minus 1. Alright, so let's figure out f prime x. So the f prime x will be negative 2x times sine x squared plus 2y and plus e to the power of y squared, that's f prime x. So let's figure out f prime y, which is the partial derivative of this implicitly defined function with respect to y, and that'll be equal to negative 2 sine x squared plus 2y and plus 2yx times e to the power of y squared. Okay, then let's put all these things into the formula. So we get negative 2x times sine of x squared plus 2y plus e to the power of y squared, and divided by the next thing, negative 2 times sine x squared plus 2y and plus 2xy times e to the power of y squared. So you can always put your answer in the simplest form. That's what we need to do, okay? Especially if we're trying to deal with calculus problems, we need to put all our answers always in the simplest form. So if I try to put this answer in the simplest form, we're going to get this one, 2x times sine x squared plus 2y minus e to the power of y squared divided by 2xy times e to the power of y squared minus 2 sine x squared plus 2y. All right, this is going to be our final answer. So basically, it's pretty safe to apply this method, this shortcut method, into all kinds of implicitly defined functions to get the derivative. Alright guys, thanks so much for watching this video. Please stay tuned for the many more calculus related videos. Thanks so much for watching. Don't forget to subscribe, like, and share and comment. Thanks. Bye bye.